we've learned how to read files in um, using sort of the built-in Python functionality, but when we're given a data file, like for example a CSV, which is comma separated values, um, it can be really nice to read it in using pandas. So I'm just going to import pandas as PD. Um, Again, we're just aliasing the package pandas to a shorter name, and we're doing this because it's really commonly done. And so this is, if you look through tutorials or anything like that, this is sort of just like what everybody does, and so everybody keeps doing it. But it's nice and short, so that's nice. And so one thing that we might need to do, so if I try to do the sort of built-in pandas CSV reader is pd.read_CSV. So I'm just going to try this out. So I'm going to pass in the file name, imbd1000.csv, and I'm just going to try this. And in this case, I'm getting an error that the file is not found. And the reason for this is that I'm actually running Python sort of in a different location on my computer than the file is. So if you remember, when we were working with files, we always, if we wanted to access them using that sort of relative path name, just saying, look in the folder where I am right now, they had to be in the same folder as our file, like our Python file, and our, say, .csv or .txt file had to be in the same folder. Since I think that when we're working with data, it's really nice to sort of work in what I'm going to call an interactive sort of way, where we're just able to issue commands to Python, get information right back. I'm actually going to move my sort of Python to the same folder that my file is in. And how I'm going to do that is I'm going to import another package called OS for operating system. And what OS does is it allows me to sort of access some of the information about my computer itself. So if I call something like os.getcwd, this is saying get the current working directory. And so by doing this, I can see that my current working directory is documents. And so I kind of have two options here. I could change my working directory to be where my file is, and I'm just going to go ahead and do that. The other thing, I could move my file to here, or a third option would be use a absolute path to get to my file. But I will personally use os.chdir, which is change directory. And so since I put my file in, I know it's in Lucia Williams CSCI 127. So I'm going to change to this directory. So if you're able to do this, so wherever you saved your file, you can change to that directory. Or you could use this information and put your .csv file into this folder. But so I'm gonna change my directory, and now if I say pd.readcsv of imbd1000.csv, I'm getting some output here, so I know that it's working. And I'm actually going to save it to a variable called data. So I'm just going to copy this previous line right here and say, okay, assign the variable data to be whatever pd.readcsv returns to me. So, so we have this variable data that we have assigned to be the output of pd.readcsv of our file name. We could do something like, okay, what's the type of data? Okay, we're seeing it's a data frame. So the basic sort of object that Pandas gives us is called a data frame. And what a data frame is it's basically a table of data, kind of like if you were to open Excel. what you would see there. So if I want to look at just some of my data, let's try print data.head. And what this data.head command does is head is actually a common sort of computer programming term for the front, like the head of your data, the very first part. And so by default, head will return to you the first 5 rows of your data and all of your columns. So in this data set, we have I'm just going to type data.dtypes, and this is showing us all of our column names and what kind of data they are. So we have, for example, our first column is called star rating, and we can see that it's a float. We also have a data type or a column called title, which is Pandas is telling us it's an object, but that can also mean string. And so title is a string. We also have something called content rating, a genre of our movies, because IMDb is, I think, some sort of movie rating database, movie information database. We have a duration, which is an integer. And there's also a list of actors, which we're seeing here. And so when you're first looking at your Pandas data frames, if they're too wide to be displayed, you'll get this compressed form, which might be a little unsatisfying, because when I said data.head, I wanted a nice little preview of my data, right? But I'm not really getting that. I'm just getting my first column, ... my last column. And so if I want to see some information about my columns, I can say data.dtypes, which is going to give me all of my list of columns and what sort of object they are. We can also look at another sort of common computer science term is tail, which is the opposite of head. So data.tail is going to give us the last 5 rows. And one sort of hint that we get that we're looking at the last 5 rows here is that on this side, we'll talk about this later, but when we did data.head, we saw, oh, okay, this was the 0th entry, the first entry, second entry, etc. Whereas when we do data.tail, we're seeing, oh, this is the 978th entry. And so if we want to just confirm what is we'll say shape of our data, we can say data.shape, and this accesses an attribute of our data frame. Can anybody have a guess what these 2 numbers here, like how can we interpret these numbers?
Rows and columns.
Yeah, so this is saying our data frame data about IMDb movies has 979 rows and 6 columns. And so if I wanted to say assign these to variables, I could say rows is data.shape at 0, because data.shape is giving me back a tuple, which is like a list. And so if I wanted to access the first element in that list, I can use my indexing operator. And so now, let's say my program needed to know how many rows I had. Now I have a variable telling me how many rows I have. So data.shape gives us rows, a tuple of rows and columns. And so if I wanted to save my columns as a variable for some reason, I could do data.shape at 1. And now I can always access how many columns do I have. Another thing I can do is I can get a sort of summary of my data, summary of the numeric columns. If I say data.describe, And so here I'm getting just an overall description. How many, for star rating, how many entries did we have? 979. What was their mean? 7.88 or something like that. What's the mean duration, etc. What's the maximum duration and the minimum duration? So it looks like we have a 242-minute movie and a 64-minute movie in here. Any ideas about why I'm only getting 2 columns here when I call data.describe, even though we know that we have 6 columns, right? Yeah, so in data, only when I said data.dtype, data.dtypes, only 2 of these were sort of numeric types, right? Both int and float are numeric types. And one thing that Pandas does that is convenient but can also be confusing is that Pandas will automatically sort of only apply an operation to the relevant columns based on their type. So when I do something like data.describe, this is saying, produce this numeric summary of my data. That only applies to the numeric data, and so we'll only get back information about the numeric columns. So even when, like count would have been relevant for all of my columns, right? Like I could have counted up how many entries there were in the, say, title field. There would also be 979, but this is just the way that it works, which can be really convenient, but can also be confusing. And we'll see that a couple other times today. One useful thing we might want to do is just inspect a specific column. And there are actually 2 different syntaxes that you can use for that. So if I want to look at the titles, I can either use the dot notation here, which is saying, okay, from the data frame data, give me the title column, just because that's what it's called here. And I just know that idle will not actually print this for me, so I'm going to go data.title.head, because I can actually call .head on a column as well. And so here I see, yes, indeed, it looks like these titles are strings, and these are the first 5 in my data set. I could also access columns using sort of more like the slicing notation that we're familiar with, or sort of similar to the syntax we use for dictionaries. Let's look. How about we look at the actors list column this time, and again I'm going to call .head just because I know that that idle will not display me all of my whole list. And so here, this is just an alternative way to access the columns, and you can use either one. It doesn't matter which one you use. So I can either say data.actorsList or data and use this sort of index notation. And either is totally fine. And so if knowing that I can access my columns in this way, if I just wanted to know from this data set what, I guess let me take a look at my star ratings column. Oops, data. Let's dtype, see what it's called. Data, okay. So if I look at my star rating column, maybe I look at the top, star rating .head. I notice that these are descending. And so assuming that my star rating column is sort of sorted, so my highest rating is my first, and my lowest rating is last. Can anybody tell me one way that I could just see what's the worst rating that any movie got in this data set? Yeah, so if I just look at the last one, I'll see the worst rating. So what's something that we've seen that allows me to see the last one? Yeah. So as just a quick check, if I was like, whoa, I really want to know what the worst rating in here was, I could say data.starrating.tail, and like we said, this will give me the very last ones, and I can actually see that a whole bunch got 7.4, but since I know these are sorted, I know this is the worst rating. So I can get some sort of summarizing information about my columns. If I say data.duration.sum, any guesses about what this is going to do? Yeah, so there are, almost 1,000 movies in here. If I sum their durations, I get 118,000. That seems pretty reasonable. I can also get their means. There are other sort of summary statistics that you can look up the documentation for. Another thing I can do with columns is I can actually get back just a subset of my columns. So if I just wanted, I know that my data set has 6 columns, but if I wanted only, say, 2 of them or 3 of them, I can pass in a list to my indexing syntax here. And what this will give me, I'm just going to print the head because I know that idle won't like it if I give it the whole thing. So here I've filtered my columns to include only star rating, title, and genre. And now, since I have fewer columns, I actually get a sort of nice output here, right? Instead of my ... And so this is one kind of nice thing about, we saw that there are 2 ways to access the columns, the dot notation and also the square bracket notation. The nice thing about square brackets is if I give it a list, then I can actually filter to a subset of my columns. And so if I want just one column, I can give it just one element here. But if I want 2 columns, I have to give it a list. So if I said data at star rating and title, I'm going to get an error. And look, because it needs a list if I want multiple columns. Are there any questions so far? Yeah, so if I want to sort of take a subset of my columns, but I want more than one, then the syntax is I have to pass in, okay, so I use my my square brackets, but inside the square brackets, I need a list.
Oh, okay.
Yeah. And I think that actually works. I think I can always pass, even if I want one, I think I can still pass it a list. Let's see. Yeah. And I think that does the same thing. So, let's try it. Yeah. But if I only want one column, I can just, in my square brackets, I can just put the string. But if I want more than one, I have to give it a list. Just a thing that I mess up all the time, but just got to remember it. So some of the real power, I think, of Pandas comes from the sort of quick ability to filter the data. So let's say I wanted to only get, I wanted a data frame that only included movies that had a high rating, right? So I have this whole data frame called data, And if I want I'll show you how I filter it, and then we'll kind of go into the details of how this works. So if I want only movies that have, let's say, greater than 8.7 rating, the syntax here is the square brackets, and let's just see what this looks like. So when I say data and then I use my square brackets and I say data.star rating, it's greater than 8.7, I get back 15 rows, and I see that I'm only getting the movies that had a star rating higher than 8.7. The reason this is working is that when I actually say data.star rating greater than 8.7, what Pandas is doing here is, and let's see if this works, is for every item in this column, it's saying, is it true or false? Is it greater than 8.7? So let's just look at the first. So since these are sorted, we know that this first one is greater than 8.7, second one's greater, etc. And then this is called, in some cases, if you're like reading about data analysis, this is called like a mask, I think, where for every row of your data set, you're either getting a true or a false, and then you're going to include based on that true or false value. And so here I'm including only the rows where data.star rating was greater than 8.7. So that evaluated to true. But for the purposes of this class, if you just remember that, if you remember the syntax for this, then that's fine too. What was I going to say next? Okay, so let's say, so I know how to filter my data to, say, only get highly rated films. Here's a question. Let's say I wanted to view the titles of these films. So I know there's 15 of them, but when I do that filtering, I get all 6 columns. Let's say I want the titles only. Any ideas about what I could do to this command to view only the titles? View the title column only? What was that? Yeah. So what this filtering does, it just gives me back a data frame, right? I can just treat it like any other data frame. And what can I do to data frames? I can take only a subset of their columns. And so I can, if I want to look at just the title column of this data frame, I can use either what I'm calling the indexing operator, but the square bracket syntax here, or completely equivalently, I could have used my dot title way of accessing columns. And so one thing in Pandas that you'll see a lot is this sort of chaining together of like operations, right? So here we chain together the filtering our rows based on the star rating, and then we chain that with filtering our titles or filtering our columns based on a certain column name. So if we just, maybe we look at our D types again. So are there any other sort of ideas that we might have for something to test out for filtering? Like anything in here we might want to look at? Just from an audience suggestion. Yeah, I think genre is a nice one. So one trick that I use a lot, if I want to see what are sort of the unique values in a column, I will use the .unique method of on this column. And so what this is going to do is it's going to return me actually a NumPy array of the unique values in this column. And so here I can really confirm, okay, these are definitely strings. And I can see we have crime, action, etc. And so now that I know what's in here, I could filter on, let's say I wanted to just get the history movies from my data set. If I say data.genre, and then here I'm going to say my genre needs to be exactly equal to history, and I'll do .head just because if there's a lot, it won't print it out. But there's not a lot. There's only one movie in my list that is a history film. And if I wanted to see what was the title of that film, just like we saw already, I could chain together. I'm only wanting the title column, and so now I see, oh, okay, looks like I'm not sure what this movie is, but must be a history movie. Any ideas about what it might look like if I wanted to filter not just on one column, but also on a second column? Like, what if I wanted action movies with high ratings? Let's say greater than, we've done greater than 8.7, so we'll just keep on going with that. So any guesses about how I'm going to perform this filtering? Yeah. So we've already seen that we can use things like, okay, if x is 7 and y is 14, if I want to test like x is greater than 8 and y is greater than 15, what am I going to get here? This is saying this statement should only evaluate to true if the thing on the left is true and the thing on the right is true. And so because y is in fact not greater than 15, I guess x is also not greater than 8. Didn't even notice that. But if I had x is less than 8 and y is less than 15, we would get true because both of those things are true. So I point this out not just as a review for the final practicum, although these are things that you need to know for the practicum, but also to point out that, unfortunately, in Pandas data frames, the same ideas apply, but the syntax is different. So what we need to do is, first off, we're going to need to put parentheses around our two conditions. So we're going to have condition 1. We're also going to have to use this ampersand instead of an and. And then we have to put a parentheses around our condition 2. So just in Python, we didn't have to put parentheses around these because of the order of operations. When we're filtering our data frames, the order of operations is different, and so we have to put parentheses around these. So, but luckily, the same syntax from before in terms of like how do we actually specify our filtering, that does carry over. So if I say I want star rating greater than 8.7, and I also want genre to be action, this is the syntax that I can use here. And so I'll just say .head. It looks like actually there are only 3, overall there are only 3 action movies that had a star rating greater than 8.7 and were action movies. And again, if I wanted to know what those were, I could say .title and I would see, okay, Dark Knight, Inception, and Star Wars Episode 5.
Is there a limit to how many of those you can use, or can you just use as many
That's a good question. I am assuming that there is no limit, so like we could say something like, we'll test it out. Let's say, and I also want long movies, so let's say I'm going to say data.duration is greater than 200. So this is saying, okay, has to be greater than 200 minutes, action, and 8.7 or greater rating. And let's see, it looks like in this case, there are no movies that uh, fit those parameters, but maybe if we say greater than 150, maybe we can. So there's only one movie that's at least 150 minutes long, action, and highly rated.